Okay, our last maths lesson for Lolly Week and our last one for the term. We're going to do a bit of probability. So, to start off with, you're going to need to get your lollies. Now, it's best for this that you use ones like Skittles, M&Ms, Smarties, something where, or jelly beans, something where you can't tell by touch which one they are. So the raspberries, for example, we used versus the pineapples, you can feel the shape as you're pulling them out. Obviously, you can definitely feel the bananas. So you want to have something where you can't tell when you're taking it out which one you're getting. So I can't tell as I pull this out of the bag what colour it is because they all feel the same. So what you're going to do is you're going to take 12 out of that bag. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now that was quite lucky. Let's replace that with that. Let's sort them into colours first. So orange, blue, red, green and brown. And what I need to do, I only want 4 colours. So I need to pick one of these, I'll put it back in and keep taking out until I get one of the colours I already have. So let's start. So let's start with orange. Now, the fraction of orange M&Ms I have is 5 out of 12. Okay. The fraction of blue I have is 3 out of 12. 12. Or 1 out of 4. Red is 3 out of 12 or 1 out of 4. And green is 1 out of 12. Now we need to convert it into decimals. Now this one's going to be a little bit tricky. So it's 5 divided by 12. I'm going to have to draw some decimal points. So 12 goes into 5 0 times. 12 goes into 50 4 times 2 remainder. 12 goes into 20 1 time 8 remainder. 12 goes into 80 6 times 8 remainder. 12 goes into 80 6 times 8 remainder, and that would go on forever and ever and ever. So what we're going to do is we're going to stop there. So the decimal is 416 thousandths with the 6 recurring. That means that 6 would continue forever and ever because you'd always have remainder 8. So then you'd have to work out 12 into 80 and so on. Now let's work out the decimal of blue. 1 divided by 4. I'm going to need some zeros. 4 goes into 1 0 times. 4 goes into 10 2 times 2 remainder. 4 goes into 20 5 times. So that means the decimal probability is 25 hundredths. And I don't need to do the calculation again. This is the same. And then the probability of green. One divided by 12. 12 goes into 1 0 times. 12 goes into 10 0 times. 12 goes into 100 8 times, and 4 remainder. 12 goes into 40 3 times, 4 remainder. 12 goes into 40 3 times, 4 remainder, so on. So again, we can stop there because that 3 would continue on forever and ever. Ooh. So it's 83 thousandths recurring. Now let's convert them into percentages. So 416 thousandths is 41.6%. 25%, 25%, and 8.3%. So now we've got the percentage likelihood of these colours. What I need to do is then take a cup, and it's good to use a cup because you can't, again, see what colour you're choosing. Put all of them into that cup. What you're going to do is randomly, keeping in mind the probability. So what this tells us is, for every time we pull out a green, we should pull out 5 oranges according to probability. But is that the case? So let's go orange, blue, red, green. Okay. So what I'm going to do, take one out of time, orange. I'm going to do this 50 times. Orange. Orange. Blue. 4. Blue. Red. 6. Red. Orange. Blue. Okay, so that's 10. So even though probability says that there's more of a chance of getting orange than blue, at the moment, orange and blue are the same. Let's keep going though. We're going to do it 50 times. So first green. 20, 24, 25. Halfway there. $15, $25, $27, $32, $34, $35, $15 to go. $30, $35, $36, $37, $20, $30, $35, $41, $42, 8 to go. Keep losing count. 5, 10, 15, 20, 25, 30, 35, 40, 46, 47, 3 to go. 1, 2, 3. Okay. So orange came up 23 times. Blue 16, red 9, green 2. So even though these had the same percentage, they were a fair way off. This was probably closest to the predicted percentage. So then our next step is to graph those results. So I've got orange, red, blue, green, and red and green. Now I don't have all those colours here, so I'm just going to use blue. Now I need to think about my scale. My biggest number is 23. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could do each one is 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and represent each one as I go. So 23 using a ruler. That way I know how far to go across. 23, Okay, blue was 16. Again, I'll rule the line up so I know how wide to go with my line. 16 is about here. Nine. This one will be easier. Ooh. And 2. So there's our first steps. So now, our next one is we're going to change 4 of the most probable with another 4 random colours. What I want you to do is I'd like you to pause the video and I'd like you to do these steps in your booklet now. And then when you get up to here, please pause and I'll show you what to do. So, change 4 of the most probable with another 4 random colours. So I need to take out 4 orange, put them into the bag, and I need to take out 4 M&Ms as long as they are blue, orange, green or red. So there's 4, but I'll have to put the yellow one back. There we go. Taking out 4 new ones. So now we have blue, red, green, orange. I didn't replace any of the orange. So blue was 5 out of 12. And remember, that was, which is 41 6/10 recurring. Red is 4 out of 12 or 1/3. Green is 2 out of 12 or 1/6. And orange is 1 out of 12, which if we remember from before, was it 3? Yeah. Okay. Now let's find the decimal and percentage. 1 divided by 3. 3 goes into 10. 3 times 1 remainder. 3 goes into 10. 3 times 1 remainder. So it's 3/10 recurring. And 1/6. 10. 1 time 4 remainders, 40. 9 times, 6 times 4 remainder, 6 times 4 remainder, and that would go on forever. So we can cut it off here. And we can write that as then we need to do the percentage. So this is 33. So we need to still add that decimal in just for our percentage. Same thing goes here, 16.6%. And then you're going to return all of those to the cup. And 50 times, you're going to pull one out at a time. Tally your results. Then you're going to graph the results again, just like we did here. And after you've graphed the results, I'd like you to repeat it 2 more times. And then I'd like you to write a short reflection where you look at, is the probability accurate for what ends up happening? Because if I was to look here, let's have a look. The probability. Probability said I should have got the most orange. Yes, it was accurate. I should have got the least green. Yes, it was accurate. I should have got the same amount of blue and red. No, it wasn't accurate. So you can have a look at, is the percentage always reliable? Or is it just going to give you a rough idea of what's going to happen? So work through that and complete the booklet and upload that at the end. I hope you've enjoyed the week. I hope you've had some good lollies out of it or whatever you've used. And we will see you back online at the start of next term, but then hopefully as soon as possible back face to face. Thank you.